Okay, we have to another interesting integral. This one was suggested by Sid. We have the integral from 1 to 45 of x, natural log x minus 1 squared times x plus 1 squared dx. Okay, this one was pretty unique looking, especially with everything going on inside the natural log here. And I think that's where I want to start. I don't really want all this here. But since both these terms are squared, I think I can just multiply it together and I can write this as x squared minus 1 all squared. But then this is going to be inside the natural log, and then by log properties I can take this 2 and bring it out front here, right? And we're going to have this x. So what this is going to allow me to do is rewrite the whole thing like this. We'll write it as 2x natural log x squared minus 1 dx. And this is still kind of a lot going on here, but what we can do is now we can do a u substitution because we've got the derivative. If I set this equal to u, we're going to have the derivative right here. So let's go ahead and we'll make the u equal to x squared minus 1, and then du is going to be just 2x dx. I'll go ahead and substitute over here first, plugging 45 in. 45 squared is 2025, minus 1 gives me 2024 for the upper bound. That's pretty suspicious. Then we plug 1 in here. 1 squared minus 1, lower bound is going to become 0. This here is just going to become natural log of u, and then everything else is just du. So for this integral, I'll use a formula. The integral for natural log of u is just going to be u ln u minus u. And we just need to evaluate this from 0 to 2024. First, we'll evaluate at 2024. So we're going to get 2024 natural log 2024 minus 2024. And then for the second part, minus, we plug in a 0 here. Let's kind of do this a little carefully. So we're going to have 0 natural log of 0. So this is actually an indeterminate form here. We'll come back to that in a second, but then we're going to have this minus 0 at the end. So this piece is going away, but let's actually just deal with this right here. Let's just deal with this over here as a limit real quick, and then we can finish it off. Okay, now for this piece right here, usually I just remember the answer to this and I just move on, but you also can do out the limit, and sometimes that's the way to go. Maybe your teacher wants you to do that, and it's nice to know how to do that. So what this is really going to be, we want to look at this as the limit. Our variable was u, so it could be whatever, but so we're saying we want the limit as u goes to 0 of u ln u. And as we saw here, this limit's actually an indeterminate form because this right here, this is the same thing as 0 times this here is minus infinity. And so looking at this, we're not sure what's going to happen, but what I can do is I can take this and kind of bring this u into the denominator and rewrite this. We can write this as limit as u goes to 0 of natural log u over 1 over u. Then doing it this way, we can use L'Hopital's rule on this, take the derivative of the numerator and denominator. So what we're going to want is still a limit as u is going to 0. Derivative of natural log u is going to be 1 over u. Derivative here is going to be minus 1 over u squared. But simplifying this, what's going to happen? We'll have the minus sign, but then the u squared, we flip it, and we end up with u squared over u. But then we can cancel u with one of these. But now for this limit, we can just plug in the 0. We can see this limit is going to be just 0, which means we can just get rid of this here. So for my final solution, we just have 2024 times natural log 2024 minus 2024, and that's it. Okay, that's it for today. Thanks everyone for watching. Have a good day.